Hey y'all, my name's Sam and I'm a math tutor here on Wyzant. The problem here is that we need to find the equation of a tangent line to the curve. The curve is f of x equals 2 to the x at the point 0, 1. Okay, nice. So I used Wyzant's graphing utility to plot the function 2 to the x, and the point of interest is when x is 0 and y is 1 right here. So of course, this is just kind of a prediction. I'm not going to use this sketch to give me the total complete answer, but I'm noticing that the tangent line, also defined as kind of the line extrapolated from taking the slope at this point, or the line that kind of butts up against our function at this point, looks something like this. It's not perfect, but it's a good sketch, in my opinion. We notice that this has a positive slope because it's going from the bottom left to the top right. And it also has a positive y-intercept. It looks like the y-intercept might also be 1. It would make sense because the tangent line actually has to cross through the exact same point as the point of the function itself, 0, 1. So let's use this as a guide to make sure our answer is correct. Just like any other line on a graph, a tangent line has the form y equals mx plus b, where our purple m is the slope and the red b is the y-intercept. I personally like to begin with slope because it's a little bit harder. And let's see. Let's do it this way. Great. We know that slope is defined as rise over run, or the change in y over the change in x. We typically write y2 minus y1 and x2 minus x1 in earlier levels of math, but when we get to calculus, we change it to dy over dx, where d implies a very infinitesimally small change that's basically approaching 0 because it has to do with the limit definition of a derivative. Okay, so in this particular case, we need to differentiate our original function to get the slope for this point. So our original function was 2 to the x. Then we kind of need to rewrite it to help ourselves here. 2 to the x can be rewritten as e to the natural log of 2 times x all in the power, still over dx. And we kind of have a nice outcome here. There's a very particular reason we did this. It's because e to the something differentiates to b itself. But unfortunately, it's not just e to the x, it's e to a function of x. So the chain rule tells us we need to also differentiate that function of x, which was natural log of 2 times x. Well, that's not too bad though, because it's any coefficient times power x to the power of 1, just gives us that coefficient. So our answer should just be that it turns into a coefficient, and we multiply it by the first derivative given the chain rule, right? So we get natural log of 2 times e to that function of x is our answer. But that's kind of a generic answer, and we want to make it, oh, I'm sorry. First of all, we can simplify it so it looks a little less terrible using kind of the inverse of what we did originally and get back to 2 to the x. And in general, this is maybe a good one to memorize, so you don't need to go through this whole rigmarole with the chain rule every time. That instead of rewriting it with e to the natural log, yada, yada, you can just remember that you do the natural log of the base when the base is not e times the original parent function that you started with when you differentiate. When x is 0 at our point of interest, we'll get natural log of 2 times 2 to the 0th. 2 to the 0th is just 1, based on the identity property multiplication, or the idea that anything times 1 is just itself. We'll get, oh yeah, natural log of 2 is our slope at that point. We've got the m done. Now we need to worry about the b. The y-intercept is basically how high up or down the function goes. And of course, we can use our y equals mx plus b. Let's replace it with the values we know. We know that y is 1, our slope is natural log of 2 at this point, our x is 0, and our b is unknown. Well, this is kind of convenient. Natural log of 2 times 0 is just 0, so b must equal 1. When you put it all together, oh, sorry, I'm pretty confident that our tangent line has the form y equals natural log of 2 times x plus 1. Natural log of 2 is a number slightly below 1. Yeah, it's 0.69, which means that our slope is kind of shallow. It's shallower than y would equal just y equals x, right? And then we also moved it up 1. So it kind of matched our prediction. I'll just write here that the slope of this tangent line is natural log of 2, which is less than 1. All right, hope that helped. Thank you so much.